Hi, myself, Professor H.K. Bangale, Department of Electrical Engineering, SND College of Engineering and Research Center, Eola. I welcome you in video lecture series of Basic Electrical Engineering, a first year engineering course. We are discussing on DC circuits. So today we will discuss the topic of star delta transformation. So while analyzing the circuits, number of times you need to reduce that circuit. And that time, by using a simple series and parallel combination, it is not possible to reduce that particular circuit. That time, we need certain star and delta conversion. So let us see how can we convert star to delta and delta to star transformation. So first we will see star delta transformation. Now we can now solve simple series, parallel or bridge type resistive networks using Kirchhoff circuit laws, mesh laws, nodal analysis. So all these techniques we are used, but in a balanced three-phase circuit, we can use different mathematical techniques to simplify the analysis of the circuit and thereby reduce the amount of maths involved, which in itself is a good thing. Now, standard three-phase circuits are networks that takes on two major forms with names and that represents the way in which the resistances are connected. And that connection is termed as a star-connected network, which is also symbolized by the letter Y. And second method of connection is a delta-connected network, which has the symbol of a triangle called as a delta. If a three-phase, three-wire supply or even three-phase load is connected in one type of configuration, it can be easily transformed or change it into an equivalent configuration of the other type by using either the star-delta transformation or delta-star transformation process. Means we can transform a star network into a delta one or a delta network into a star one. So resistive network consisting of three impedances can be connected together to form a T configuration. But the network can also be redrawn to form a star or Y type of network as shown below. So here delta to star transformation network is shown here. Now we will find out how to transform a given delta network into equivalent star network. Okay, so delta star transformation to convert a delta network to an equivalent star network, delta network into equivalent star network, we need to derive a transformation formula for equating the various resistors to each other between the various terminals. Now consider the circuit here. This is a star connected, sorry, it is a delta connected network. These three resistances A, B, and C are connected in a delta fashion, that is a triangular fashion. And the vertices of this triangle is, let us say, one. First vertex is denoted by letter number 1, second vertex 2, and third vertex 3. So this is a delta network. Now this network we have to transform into such a Y network, sorry, such a star network. Okay, so this star network, let us see this terminal 1, terminal 2, and terminal 3. These three resistances are connected in a star fashion. So compare the resistances between the terminals 1 and 2. So here between these terminals 1 and 2 in star fashion, the resistance P and Q is there. And these both are in series. So the series combination between the terminals 1 and 2 is P plus Q, and their equivalent resistances in between terminals 1 and 2 in this delta fashion is, if you look in this direction, then This A resistors is connected in parallel with the combination of the series of B and C resistors. Means we can compare these resistances between terminal 1 and 2 in between star and delta, and it finds that P plus Q in star is equal to the equivalent in delta fashion is always A in parallel with B plus C. Means P plus Q is always equal to P plus Q is always equal to, this is a parallel combination, that is R1 R2 upon R1 plus R2. So it is A into B plus C upon A plus B plus C. So here we will get the first equation. So remember this. Now resistance between terminal 2 and 3. Here in star fashion, resistance between terminal 2 and 3 is Q and R connected in series, means Q plus R. And here in between 2 and 3, their equivalent is C is connected in parallel with the series combination of A and B. So I can write Q plus R in star fashion is equal to, in delta fashion, C in parallel with A plus B. So Q plus R is equal to C into bracket A plus B upon A plus B plus C, like this. Q plus R is equal to C into A plus B upon A plus B plus C, and this is second equation we got. Now resistance between terminals 1 and 3. What is the resistance between 1 and 3 in between in this star fashion? So P and R connected in series. So P plus R or R plus P is equal to 1 and 3. That is B is in parallel with series combination of A plus C, A and C. So R plus P or P plus R is equal to B in parallel with A plus C. So I can write this P plus R is equal to B into bracket A plus C upon A plus B plus C, and here you will get the equation 3. Now this gives us 3 equations, and taking equation 3 from equation 2, it gives the equation 3 minus equation 2, we get P plus R minus Q plus R. So it is R will get cancelled, and I will get as P plus R, that is B plus B into bracket A plus C upon A plus B plus C minus Q plus R is equal to C into bracket A plus B upon A plus B plus C. So P minus Q is equal to, after solving this, I will get BA plus CB upon A plus B plus C minus CA plus CB upon A plus B plus C. So by solving this delta to transfer function equations, we will get P is always equal to AB upon A plus B plus C. So P is equal to always AB upon A plus B plus C. Q is equal to AC upon A plus B plus C. Similarly, resistance R is always equal to BC upon A plus B plus C. So come to this diagram, P is equal to, so this is the P. Okay, so the value of P is always equal to, it is always equal to, what is this P? P is equal to AB upon A plus B plus C. AB, now P is connected to terminal 1. Come to the delta connection. So here terminal 1 में कौन-कौन से resistance connected है? A और B. So these A into B will be in numerator term, and remaining sum of all is goes to the A plus B plus C goes to the denominator. So P is always equal to AB upon A plus B plus C. Similarly, Q is always equal to, Q is connected to terminal 2. So terminal 2 यहाँ पे डेल्टा में कौन-कौन से है? A और C. So it will be in numerator term. So AC upon A plus B plus C. Similarly, R is equal to, so the R is a resistance in a star fashion, and its equivalent in delta fashion is always R is equal to, R is connected to terminal 3, और यहाँ पे 3 में कौन-कौन से? BC. So B into C will come in numerator. So BC upon A plus B plus C. So in this way we get a delta to star transformation. Means if we have this delta connection, then we can convert this delta into this equivalent star connection by simply taking or deriving the values of P, Q, R resistance from these delta connections. So you remember this while solving the problem. This will be helpful to you. So now star delta transformation. Now we have seen above that when converting from delta to star network to an equivalent star network, that the resistors connected to one terminal is the product of the two delta resistances connected to the same terminal. So that we have already seen that resistor P is connected to terminal 1, and in delta fashion terminal 1 so A and B resistors are there. So their product will be taken in the numerator term, and a denominator term, the sum of the all the three resistances, that is A plus B plus C. So by rewriting the previous formula a little, we can also find the transformation formula for converting a resistive star network to an equivalent delta network, giving us a way of producing a star delta transformation as shown below. So here now we have to convert the star into equivalent delta network. So for this equation is A is equal to, now अभी ये delta में A का वैल्यू निकालना है हमें स्टार वैल्यू मिला है. Now A is connected in between terminal A and 1 and 2. यहाँ पे 1 और 2 के बीच में क्या क्या है, P and Q. So P into Q will be at the numerator. So PQ upon R plus Q. So A is always equal to PQ upon R plus Q plus P. Q plus P. Okay. Similarly, B is equal to this. B is connected with terminal 1 and 3. यहाँ पे 1 and 3 में कौन है, P और R है. So P R will be, RP will be at numerator, RP upon remaining at denominator is Q plus P plus R. 1 और 2 के बीच, 1 और 3 के बीच में जो है that is P plus R. Similarly, C is in between 3 and 2. यहाँ पे 3 और 2 के बीच में क्या है, Q and R है. So it will be in numerator QR upon remaining P plus this Q plus R. So that is the equivalent in delta fashion. Okay. So we can easily convert star into delta by using these three equations. So the star delta transformation, if Z1, Z2, Z3 are the impedances in the star network, their equivalent will be ZA, ZB and ZC in delta fashion. Okay. So likewise the same formula of conversions are there. You can convert this star to delta and delta to star by this formula. So this is okay for today's lecture. In next time we'll discuss or we'll solve certain examples on star data transformation. Thank you very much.